to be math major, okay, things like that. Okay, our topic yesterday talks about biochemistry. Now we're gonna touch with the basic chemistry. Okay, who loves chemistry? Okay, okay, we need to force to love chemistry, right? Okay, see, because chemistry is the parent science of all. Okay, even biology. Okay, biology, physics, astronomy, environmental. The center is really the chemistry. Okay, our world is chemistry already, like the atmosphere that composed of 78% nitrogen, 21%, oxygen. And the moment we will sleep, okay, we need to have this oxygen, okay, oxygen circulating like that, because the heart is the only organ that doesn't sleep. The other organs will sleep and not functioning when we sleep, but only the heart remains alive. Have you noticed that? Okay, it keeps on beating even we are sleeping. Okay, if the question will say, the only organ that doesn't sleep or doesn't stop, and the answer is the heart. Okay, that's very clear. So that's also related to chemistry, the oxygen supply for our bloodstream. When we sleep and we are alive, or we are, every morning, every afternoon, like that. So oxygen, like that, no? Mga molecules, no? Things like urine. So urine is composed of a lot of salts, like that, no? Elements again. So that's why chemistry is the parent science of all, in all pure sciences. Okay? And then it started all with chemistry talaga siya. Even though sa Big Bang Theory talks about, the collision of celestial bodies, and then it creates planets after that. Okay? If you can still remember the Big Bang Theory as the first evolution of the universe as well. Okay? Things like that. Going back here. Okay, because we're talking very, ano na, no? Okay, nitrogen reacts with chlorine to produce nitrogen trichloride. At equilibrium, the concentrations of each gas were found to be, if you see a bracket like this would mean concentration, okay? Get the point, okay? Or it could be the curve like that. It would mean a concentration, huh? And this is specifically the equilibrium concentration, not the initial concentration, and not also the concentration during the chemical reaction takes place, but rather this is the chemical equilibrium concentration. Okay, so before anything else, so we need to define what is a chemical equilibrium. Okay, chemical equilibrium means when the rate of forward reaction, which is composed of the reactant, will be equal to the rate of the reverse or the backward reaction, which is the product. So the moment they will be equal to each other, then the concentrations of the reactant and the product will remain constant, or it will never change at all. So since these are words, I need to interpret this with symbols and graph. Okay, for example, we have here the reaction of reactant A. So we need to know the concept, guys, before going to complexities. Okay, so A will be converted to B, right? So we have the arrow going to B, and after that also the B will be going back to A. So we have a reversible chemical reaction. If you see symbols like this, half arrow up and going to the left, right, and then an arrow also going to the left, and then there's a half like this, no? Okay, sharp pointed, no arrow. It's only half. But if you want also whole, no problem. This is just only representation, okay? But I love this half arrow like this, no? So, okay. Now, if you introduce 1 mole of the concentration of generic A, no? Okay, what will be happen for your concentration B? After that, what happened to your concentration A? So actually, guys, this also follows the Le Chatelier's principle. Okay? But our topic is not Le Chatelier's principle, but it's connected with each other. Okay? So this is our reaction, chemical reaction. Okay? Now, So if we add 1 mole concentration A, so what will happen to the concentration A? It will decrease somewhere along the way, and the one who will benefit is the concentration of B. The concentration of B will go up. So concentration of B will go up, and the concentration of A will go down. You get the point? And then as they go up, as they go down, until such time it's constant. The two are constant with each other, and that is the time it would establish the dynamic equilibrium. So if we try to plot or graph, okay, things like that, let's say, usually if this is under chemical kinetics kasi, or chemical reaction engineering, okay? So if we have, let's say, concentration vertical, and this is the time here, okay, things like that, okay, time in the horizontal, this is the concentration here, okay, things like that. So our concentration A will go up here, like this, and until such time it became constant here, straight line, okay? So it's increasing as I expressed here. So check. Okay, increasing, right? Okay. So concentration of A, concentration of B. We can show this in the graph. So the increase C B. Okay. So the decrease C B A. O si A. Sorry to say, nabali ako ganina primero, no? So this is A. So things like that. I'm only speaking the reverse, but my mind is correct. Ito pala sa corrected easily. Okay, things like that. Things like that. So here, kasi this is the concentration of A. Can decrease, no? So decreasing. This is the concentration of B. Okay. Now they are, in a straight line. Concentration of B, concentration of A. So the two straight lines would mean the equilibrium or the chemical equilibrium, or we can say the dynamic equilibrium. Okay, so dynamic equilibrium is the appropriate term because after this, maybe they will rise again, they will lower again. It depends on the different parameters you are able to change somewhere along the way, or other factors, that affect our concentration. Okay, so dynamic equilibrium. Don't forget this one, ha? Dynamic equilibrium or the state of dynamic equilibrium. Okay, kani siya nga term. Okay? Now, straight line and you draw a vertical line here. Okay? At this time, your rate of forward reaction is equal to the rate of your backward reaction. Okay? Things like that. Okay? Now, if we plot the concentrations versus time also, this is the concentrations versus time, and we need to have the rate of reaction versus time. Okay? Things like that. So remember always that during the plotting, the time will always be in the horizontal axis. Okay? Things like that, so that it's easy to remember. Okay? Things like that. And now we go to the rate of reaction. So this one is RF, and this one is RB. So if this is the rate of reaction in your vertical, no? So this is ROR, no? Rate of reaction. ROR, rate of return. Okay, so we have your time. Okay. Okay, so RA na to, the same story. RA na to, decrease. Like this, okay. This is RA. RB also decreases, no? Okay, like that. But the only difference for the increases, sorry, RB is also increases, no? Increasing ang RB and decreasing ang RA. You get the point? So, in this case, RA is equals to RB. Okay, so notice in the rate of reaction, rate of forward and backward, so they meet each other. This is the only difference. In the concentration versus time, they will meet each other. Okay, but still they are going to horizontal line. Both are going also horizontal line, but they are meeting with each other the line, no? Things like that here. So this is now called the chemical equilibrium. Chemical equilibrium. The slight difference between chemical equilibrium or the state of chemical equilibrium, let's make this very minor difference because it has the same connotation. The minor difference of the two between the state of chemical equilibrium and the state of dynamic equilibrium, because the state of chemical equilibrium, the rate of forward reaction and backward are equal, but it will create one line during the as it progresses, no? But the state of dynamic equilibrium, the concentrations will just remain constant. A and B will not change, and they will not create one line somewhere along the way. Okay, you got the point. But that's very close with each other, no? Because what will come out in the board examination is the dynamic equilibrium, the state of dynamic equilibrium. Who knows also will the chemical equilibrium will also be come out, no? Okay, why is the state of dynamic equilibrium will come out? Because this is not usually discussed well by teachers because they focus on the chemical equilibrium, the state of chemical equilibrium. Because si dynamic kasi ano lang siya it's like pahabol theory. It's not really the main concept of it all. Okay? Things like that. So, wala siya ma-emphasize ang state of dynamic equilibrium. Okay? Things like that. So, the definition of chemical equilibrium is a man with the rate of the forward reaction and the reverse reaction are equal. And that would mean it will meet a horizontal line somewhere along the way. And then, okay, after that, so they are not changing the concentration and remain constant. Okay? Things like, so remain constant and not changing. That's the, for the concentrations. Okay? But the rate of forward reaction are equal. Again, it's not the rate of the reaction is not changing or constant, but rather the concentration. And this is very clear. Okay? Now, if you see the rate of forward reaction is equal to, let's say, K1, kung ang premium ang mga derivation, K1, K sub 1, K sub A, K sub B, ana-ana siya ba? K sub 1, okay? Then concentration of, let's say, ano siya, no? A. Because this is, the forward. Okay, the RB, diba? RB is K. So what you will put, K2 or K negative 1? Okay, by understanding, you can also put 2, but it's nice to put negative 1 because this is the direction opposite to K1. So that is negative 1. Okay, negative 1. Or you can say also K2, it depends on our understanding, as long as that is the rate of reaction or the opposite of the rate of the reaction of the reactant. Okay, this is B, ganern. Diba? Okay. And then to establish the equilibrium constant, because this chemical equilibrium, we need to determine the KAQ. Okay, get the point? So the KAQ, so how can you determine for that? So we're gonna take the ratio from RF over RB, ganon, is equals to K1 A, then K negative 1 B, ganon. Get the point? So, muna siya atong ratio. Okay, this is equation 1. Okay, so let's erase this. Okay, drawing here, no? So, we go to the basics talaga, no? Okay. Okay, we have this expression. Okay, now it is because our target is KAQ, we're gonna solve for the K's here, no? Constants here. So, from this equation, so we need to solve K1. So K1 is equals to RF over concentration of A. So this is equation 2. Okay, then K negative 1, same story, is equals to RB over B, no? RB over B. So this is equation 3. Now, since we're looking for the KAQ, we are focusing on K1 over K negative 1. It's not RF over B, RB. Okay? Here, rate of reaction constant is the term here. Because we are having the ratio between the reaction rate forward and reaction rate B. But we are after kasi on the chemical equilibrium constant. So we are trying to ratio the K1 over K negative 1. RF over A and RB over, okay, B. Ganon, no? Things like that. Okay. You get the point? So in order to solve for K1, what we will do here? Okay. So what we will do, what we gonna multiply, blah, 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 so and so, parang ganon, so that we can cancel that one. Saman. Okay? So, so let's multiply this with no K1, okay, things like that, and then we gonna have ABC mo na siya habilin, di ba? Oo. So K1 RF A, di ba? So if we have that case, so ma-cancel si A, K1 na mabilin, no? Cancel. K1, K1, and then RFA, cancel. Mabilin si K1, RB, B. Ganon. Okay, get the point? But napakay RFA sa ubos. You get the point? Di ba? Okay, things like that. Sige, let's continue this one. So if we try this one, okay, we multiply this to K-1 RFA so that the K-1 will be cancelled so that we can get the K1, no? So K1 over K1 -1 times ani. So cancel that is K1 RFA, no? And then ganun siya, RF, ganun siya, cancel siya the whole thing. So it will become K-1, no? And then RBFB, no? Di ba? RB, then B, ganun. Okay, get the point, no? Solve for K1, din mo na itong expression. Okay, mga palangga. Okay? So, how can we solve? Actually, guys, muna na siya ang atong K-equilibrium constant. Okay, kana siyang portion. Then we need to manipulate that later on. Kani ba? K1 over K-1. Muna na siya itong K-equilibrium constant. Okay? Things like that. So, saan man na ito pag-arrive sa atong equilibrium constant? Okay? So, atong buhaton ang pagbiga-biga. Char. Wait sa guys ha. Kaya mo inom sa tag coffee to activate our brain cells. Char. Okay. Diba? Sige. Coffee please. Magputaw sa taong init na tubig. Okay, get the point. Okay. Ang atong brain cells ato siyang i-activate. Okay? Diba? Para ma-stimulate atong mga hormones, whatever. No? Diba, guys? Okay. So, darang akong heater sa atong i-boil ang tubig. O, diba? So, muna siya atong reaction. Okay? Kani siya. Equation. And this one is your equation. Okay? Things like that. So, you can use that also somewhere in your reaction. Okay? And then, to make it simpler, okay, because this involves a lot of, see, RF, RD, RFA, RD. So, we need to make this more simple. Okay? Ako lang just show. Okay? So, let's say, kung RF, no, is equals to RB, and we have K1, okay, then this is A, no? This K-1 and B. Get the point? Things like that. Okay, mga palagingging. So how can we do that to get the K1? This is another representation. Okay, so we're gonna divide this both with negative K1, okay, and A, and negative K1 and A. Or positive K1 also will do, no? Okay, positive man si K1. Tama ba? Okay. So, K negative 1 and K negative 1. Okay. Makancel siya. So, wala na mabili ni Equilibrium constant, no? Tanawa lang nyo guys, rate of forward reaction. So, this is the definition of rate of forward reaction. K1 times A. Rate of backward reaction or the reverse reaction, no? So, si K negative 1 times B. So, we need, our purpose is to compute for the K1, no? So, and then, dapat man siya A. So, we need to avoid this A. So, we need to divide by A. And here also, napamantay K1. So, i-divide na itong K1 para makancel si K negative 1. Okay? Because we have K1 naman there, Ari. So we are computing for the K man. Okay? So, cancel, 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 cancel. For that, no? Okay, and we have now K over K minus 1 is equals to concentration of B over A. Katugaling na kasi nyo kung K negative 1 is equals to R, F ba ito siya? RB. Okay. Pwede ito siya mawala si RF of RB because they are entirely not changing in the reaction. May basta ito siya B over A. Katong gi-ratio ba? Ratio. Di ba naman to? RF over RB. Okay, na-ratio ko na ko ganina. So it will be equal to 1 because it became constant. No? Okay, it's somewhere along the way, no? It doesn't, so wala na siya yung mga changes. Kaya equilibrium naman ang atong rate of forward reaction, chemical reaction. So pareho rani, sumula na siya, okay, sumula na siya atong equilibrium constant, okay? So equilibrium constant equals to the concentration of the products, which is B over the concentration of the reactant A. Okay, so, kato A to B man to siya, diba? Things like that. So there's no number of moles. If we have numbers of moles 2 here and 3 here, so each raised to the number of mole, no? So now 2, so it raised to the power A to B3. Concentration of the product raised to the coefficient, no? Over the concentration of the reactant raised to the coefficient or the number of moles, no? So let's go to the example now because this is really hypothetical, no? With chemical reactions na yun. Okay, dito punta na siya atong problem. Okay? So we have nitrogen. Nitrogen. Ano gani guys? Nitrogen. Okay. Ang technique niya kay chemical reaction. So nitrogen gani i-react or i-add. So since you are talking about chemical reaction, it will become a diatomic nitrogen, ha? It's not the nitrogen alone. It will become N2. Okay? This is standard in chemical reaction. Why? Because it's written in words. It's not written in symbols. Uban ani mayabo. Okay? Because what is written, they cannot express in a chemical reaction properly. Kaya anak naman tayo, nitrogen react. Isuot na po nila ang nitrogen. So, di ba? This is for analysis. You get the point eh. I-add po nila si CL rapod. And this is bad. You get the point? Okay? Yung mapulos sodium chloride. Dili si nitrogen trichloride if that is the case. So this is confusing, right? See, nitrogen reacts with chlorine to produce nitrogen trichloride. Mention na si nitrogen trichloride. So obviously that is this is not a redox chemical reaction. Kung imo i-add si nitrogen o si chlorine, redox na siya. It will produce sodium chloride. Yeah. Then chlorine man na siya negative nga charge. And then si nitrogen, imo ko ano siya? No, this is nitrogen chloride, dili sodium chloride. Okay, but this is a redox chemical equation, not the chemical reaction. So imo siyang i-into ha, diatomic yun siya, no, Fermi. Okay? So that become na N2 gas, no? G plus chlorine gas, G is equals to nitrogen trichloride. Trichloride ana siya. So nitrogen trichloride gas yapon. Gas plus gas is equals to gas. Diba? So balance the chemical reaction by visual inspection. No? Things like the 2, 2, so we're gonna put 2. Magkuha lang ta dire trial and error method because If you try to use the algebra balancing chemical equation, no challenge. It's easy. You get the point? See? Nitrogen 2, like chloride 6, so you get put 3 here. So it depends on the situation. If the chemical reaction is very easy to balance, no need to use the algebra balancing of chemical equation. But if the chemical reaction is very complex, like involving hydrocarbons with higher number of atoms and moles, then that's the time you use algebra balancing of chemical equation. Trial and error method is very difficult na. Here is very easy, the trial and error method. Okay? So what mo say atong algebra chemical reaction balance chemical equation, that's easy already. Okay, get the point? Oh. So things like that. Trial and error lang ko para dito. Okay? So 6 ang chlorine, 2 ang nitrogen, 2 ang nitrogen. Okay. So at equilibrium, the concentrations of each gas are found to be N2. Di ba? So this N2. Okay, get the point? Mga ganon. Okay, guys? Sorry guys Okay, things like that. Okay, managed me. Charot lang. Okay. So ano siya, no? Then, kani siya equilibrium concentration. These are not initial concentration. Okay, this is not during concentration also, but rather equilibrium concentration. Okay, things like that. So, KAQ is equal to the concentration of the product, this one, nitrogen chloride. So, concentration of nitrogen chloride raised to the power 2 gas. Okay, product, then reactants. We have 2 reactants, nitrogen and chlorine. Chlorine gas, sorry. So, N2 gas, there's no coefficient, no? So, chlorine gas, and the coefficient is 3. So, raised to the power 3. You need to put the coefficient because it matters a lot in your calculation. Okay, now substitute values in Cl3. Okay, pilay mong 0.50 molar, no? So 0.50 molar raised to the power 2. Ang N2, we have also 0.15. So direct substitution or challenge. 0.15 raised 0.15. Okay, and then chlorine gas, we have 0.25. Raised to the power 3. So, direct substitution. Okay, no, okay? So, cancel ang mga molar-molar. So, there's no unit. Constant, guys, is always unitless, ha? Okay, there's no unit. Just like index, no? There's no unit. Okay, so things like that. So, what is capital M? Okay, this is molar. Okay, meaning from molarity. Okay, I must explain. Molarity is equal to the number of moles of solute, okay, over the liters of solution. So therefore, molar is also expressed in in moles per liter. So to make it direct, they will put molar, capital M. But sometimes they will also put moles per liter. Okay, or other biga. It's the point that you need to compute from concentration, blah, blah, blah. So, tagaan kag density, okay, density mass over volume, and then it will convert to concentration. It's not direct like this, no? You get the point? Ano ba? They give you the mass, no? The mass of N2. Actually, it's just like a tricky movement so that you can understand really what you are doing. Since you are getting the concentration here, then the given also is not direct concentration. So this is now not direct substitution. Nagitagaan mo kag density. Okay? So density is equals to mass over volume. Mga ganon-ganon. Okay, get the point, no? Okay? Then, so ato na nimo navigate nimo si moles. Okay? Kuha man ni concentration man ni siya, di ba? Okay. So sa formula ni concentration, number of moles over volume. Di si volume na sa density. Naklaro, no? So dali ra kay nimo i-navigate na may mass, na density. Makuha nimo si volume, pagkuha nimo ni volume, inasa number of moles, asa man, other number of moles ay 3, 2. So sa to pa makakuha, you can get concentration substitute here. So, the DC conversion is not obvious as this. Okay? But this is the simplest example all over the world. Direct substitution. You get the point? Oo. Diba? Kung the moment ganun siya nga, density ni siya, we're found to be the density of nitrogen gas is like this, the density of chlorine gas is like this, and the density of nitrogen trichloride is like this. So I need to explain this because this is not common in classroom instruction. When we deal with this topic, the teachers will always use this as is, traditional way. You get the point? But in the board examination, they will change that another quantity, and you will be shocked that you are not exposed to that kind of problem, but only the quantity is changed. They are measuring our total comprehension, if we really understand. And sometimes, it's not also discussed, no, sa mga problem solving. Okay, get the point? Since naman kay density, mass over volume, okay, then ay mga given sa mass dia, whatever, makuha volume. So, biga-biga na ni siya. Okay, get the point? What biga-biga? Meaning to say, they try to complicate the problem if you know how to make it for simplicity, from complex to simplicity. O, di ba? From general to specific. Okay? Mulang nag-start siya sa complex. Hindi kay simple naman siya, daan. Okay, get the point? Oo. So, you need to substitute na lang siya. So, 0.50 raised to the power 2 over 0.15 times 0.55. 0.55 raised to the power 3, atong equilibrium constant, pila man, no? Okay. So, ayaw mo kalimutan naman yung ani, ha? You get the point? Things like that. Oo. Okay? Things like that. Okay. Then, anak po siya sa gas, no? There's no concentration given. This is also the in-between. There's no concentration given, but the letters of solution is given for the entire chemical reaction. Nitrogen reacts with chlorine to produce nitrogen trichloride with a total volume of 2 liters. At equilibrium, the concentration of each gas were found to be the concentration ng ibutang diri ari. Okay? Get the point? At equilibrium, so na yun siya. At equilibrium, calculate the value of equilibrium constant. This is a little bit difficult. Okay, get the point? So nawala na sa concentration, then the problem is very direct, itagaan kag volume. So asa nimo navigate karon? Si volume. Klaro kay draari sa formula sa concentration, number of moles over the volume. So where can we get the number of moles sa chemical reaction? May mga moles diha, total volume. So this one divide by the volume, all because they shared the same volume because they are mixed together. So you will say 3 divided, let's say 25 milliliters. So liters, 3 divided by let's say 2 liters, so 3 divided by 2, 2 divided by 2, 1 divided by 2. Isubstitute mo diri ari. So that is also tricky question because normally also in classroom instruction, there will be no such like that. The liters of solution will be given and there's no concentration. Because in the topic of equilibrium concentration, naagyo na siya yung mga concentration. Pero, ako siyang i-articulate ang problem. In case na wala na yung mga concentration, baka sumpa ka. So this is now we call analysis. You get the point? And critical thinking. Kaya wala naman din naman siya pareho ang pagkatudlo sa teacher. Gisukod naman kung nakasabot ba jud ka beyond classroom instruction. Kaya kasagaran man sa students, they are doing the same thing typically and generally what is being taught. They will just remember how the teachers manipulate. But the moment it will be changed na medyo it's awkward and there's no identification. Others will panic, others cannot answer, or others also can answer. It depends on the IQ of the student. Okay? So muna to siya. So ano na to? Nitrogen reacts with chlorine to produce nitrogen chloride to produce 2-liter solution. Meaning to say, the entire chemical reaction solution is 2 liters. At equilibrium, calculate the value of equilibrium constant. So wala na yung mga given. So mahadlok taan eh. Before mahadlok ko because wala pa ko technique ba? Itong high school pa ko. Since I studied a lot, pwede naman siya kuan liko-liko, you get the point? Oo. So things like that. If you know the formula of concentration, because ang equilibrium constant, you were replaced with concentration kasi eh. So mangita kag pagi nga, imong ipaslak dili concentration. So you should remember for the formula of concentration. So mo think ka, what is the formula of concentration? Moles per liter, na kay liter. So yung problema, moles na lang. This is chemical reaction. So stoichiometric chemical reaction deals with number of moles man siya. So na kay mole over liter solutions, di na ka magpaabot sa concentration. No problem. But again, this is rare, no? In the classroom instruction, mga paano na siya. So, ang adaptation niya, dito na siya sa mga board exam, ang kita point na, so preparatory na siya dito. Akong point mga good guys, it's we need to train or to practice our students to learn something which is not common and not the same and not traditional reflected in the books. This is for the teachers. This is my advice for the teachers. Okay, that they will not always use the example in the books all the time. They can blend that with other strategies that looks like not the same in the books, no? Kaya mga pang-updated na type of question. So this is the moment that our students will be suffering in the future. Dahil ka ng mga exam standardized test. Because some of them don't have an idea. Makapaboran ka ng kusukin mo tuon. Okay, grabe ka naning, super naning, investigative. You get the point? Oo. Things like that. So to those typical lang nga student, magtuon lang ko na exam, impossible, kaya wala ma-discover. Okay, kaya discovery learning man yung may guys. You get the point? Oo. Because not all can think directly, manggod. Okay, what is being asked in the question? O, manana siya. Okay? So you can get the equilibrium constant for this, no? So calculator, please. So you'll be the one to solve this because it's very easy, no? 0.50 raised to the power 2, you get the answer. And then 0.15 times 0.55 raised to the power 3, you have the answer, multiply it, and then division, then you can get that equilibrium constant. No? Okay. So, okay, that is the answer now already. For calculate the value of the equilibrium constant. Now, there is another counterpart for this. No? So we have the equilibrium expression in partial pressure. Okay, KP. Nakaning KP din sa kayo ni makuan sa mga student pero namangunidaan sa kuan selection. You got the point sa si KP. Okay, so KP is equals to the product partial pressure, no? Raised to the power coefficient of that product over the partial pressure of the concentration raised to the number of moles of that concentration. Mga ganun-ganun lang. Okay? Okay, so coefficient of that concentration. Ana lang siya. So, the problem now there is like this. The nitrogen reacts with chlorine to produce nitrogen perchlorate. Okay, at a partial pressure of 2 atmosphere, ana ba? Because of phosphorus, and the partial pressure of chlorine, calculate the equilibrium constant expression KP. Gano'n, no? Si KP, KC ni siya. Okay? Muna yung counterpart. Okay. But sa board examination, ang magawa si KP, usually, equilibrium constant at partial pressure. Okay? Yeah, there's mga condition niya. Lain na pa kayong condition dito. Kaya man, if the pressure of ammonia is twice as faster, murag gisagol siya sa math bitaw nga datingan. Ano pa ba da ini? What maanad ba? If the pressure of nitrogen is twice as faster than chlorine, okay? What is the equilibrium pressure of the constant? What ana ba mga pangutana? Wa ta mag-expect na naging condition ngayon ni ana. So mabalik po kag math ato ha. Math po to siya nga interpretation nga multiply if twice maganon or more than add less than ano. The same thing ani po. So, kasi mo pasabot ato, we are navigating the math concepts to the science concept, linkage. So, muna siya makalisod manggod kay at the time nga iya mo isagol si math ang iyang concept dito sa science in which dita magdahom. Okay, get the point? Oo. Really? Okay, get the point? Oo. Diba? Yung saya gani, butangan pag yun siya current. Ang topic is equilibrium constant. Ano pa may current? You get the point? Balik na po ko dito sa current. Okay, wala man yung problema na may formula ang electricity. Sumumugo ka sa electricity nga formula despite the fact na nilibog siya sa problem because this topic doesn't need electricity. You get the point? No, but since that is an examination, gisukod ra atong pangutok ba sa takutob. You get the point? Hindi tangay maraton ko na yung magsagol-sagol nga mga quantity nga dili sa nga topic during our classroom instruction. You get the point? Or what siya? Nitrogen reacts with chlorine to produce nitrogen chloride and the viscosity of nitrogen manibong ka ano na may viscosity nga ang topic ani chemical equilibrium raman. Diba? Things is usa naman po ni Ron. Ing ana nga times guys no, wala jud kay choices. Mugamit ka og law of parallelism. You get the point? Oo. Wala bitaw gi-discuss. Kaya kani magun inyong mga iniani manggod. So it could be the viscosity, concentration, partial pressure would be directly proportional in this formula also. So imong i-substitute viscosity of nitrogen raised to the power like that over the viscosity of H like that, no? The same dito sa concept nga katong component balance sa overall material balance, no? Kung wala mga moles, mga percentage mass, kutob sa naa dito nga dimension, buhati na lang yun na siya. You get the point? Oo. Labi na i-mention ang mga individual. So it will give us a hint already. Nitrogen reacts with chlorine to produce nitrogen chloride. At equilibrium, the viscosity of nitrogen is blah blah blah. Chlorine, blah blah blah. So klaro kayo nga, mura siya, ato gyapon siya nga style, pero yung mga institute, mga viscosity na. Kaya nga naman, as I told you, equilibrium constant is unitless. You get the point? The unit of measurement would not be necessary at all. Okay, constant man. So mao na siya, kung sa pay quantity ang ikuan diya, as long as mura bitaw siya mo jive, you get the point, no? Or things like that. Tingnan mo dito sa mo increase na yung viscosity, kung increase ang concentration. Okay? Una pod nimo, you get the point, or things like that. Okay? Wala makailaing choice. Okay? Things like that. So your choice really is to achieve the law of parallelism. O pwede ka po ka law of patterning, you have to go that, or law of opposites, law of normancy. You get the point? Muna siya yung mga laws nga malinkage sa mga subject to subject nga dili mausab. Okay? First, law of parallelism, law of patterning, law of sequencing, law of normancy. Okay, you get the point? Law of the degrees of freedom, law of proportionality. There are 6 laws how to solve problems. No? This will be linkage with each other. The moment wala kang mga inguni-ani, mayabutak sa board examination. Kaya daghan dito nga, waka kasabot nga ang kanang topic, dili para dito. You got the point? Munganga ka ba na? Saan man ni? Uy, nahihit. Nisagol man si kuan, si impedance, sa electricity, si conductance. Lo? Nag-mix up bitang yung mga kuan, yung mga given voltage siyang isura guys. Nung nakailan just ay sige be, mo rin ka basta muna lang. O sige, magsugod sa primero, okay. Ganun imo itagsa-tagsa ang mga quantity. Viscosity o sa formula, impedance, inductance, conductance o sa formula. Use what is available in the problem. What is available resources for the moment to do the task mo sa diapon ang problem solving. What is available, what are spares, what are in the problem, then use it. Okay, get the point, ganon. Maghinay-hinay ka og laws, no? Ang laws of proportionality, may kasagaran. Ratio and proportion, interpolation, double interpolation, okay, extrapolation, you get the point do? Diba? Law of normancy, katong mga causation, correlation, you get the correlate ka og mga equation, you get the point, no? Patterning, naman ng patterning, you get the point? Diba? Things like, pero ang pinakasikat niya ang law of parallelism. You get the point? Sa kanami nga sa tanan nga subjects ha din sa math. Dapat dito siya law of opposites, 7 na siya opposites. Okay?